So on all of these, you first need to make sure they're in standard form. If you do have a perfect square term in the front and in the back, square root and try to plug it into your answer format. So as you can see on number 1, doing the odd ones only, odds. Okay, so number 1, what's the square root of k squared? K. What's the square root of 100? 10. What sign belongs in between? One negative, one positive. Because there is no middle term, so it has to cancel out. That was easy, right? And technically, we didn't even have to think about it that way. We could have done it the old way. What times what is negative 100? That it combines together to give you the middle value, which is nothing. Right? So right there, either way of thinking is fine. Let's jump to number 3, doing the odd ones. What do I do here? What should I do? Greatest common factor, GCF. Always GCF first. What could I pull out? A 4? And what would be left if I pull out a 4? 4p squared minus 9. Am I done? No. You always have to look at the inside. And then right here, once again, we have a perfect square term in the front, a perfect square term in the back, and we know the middle terms cancel out. So I'm going to set up my answer format. And what is the square root of 4p squared? 2p. So we're going to put 2p right here and 2p right here. And how about the square root of 9? 3. So we're going to put a 3 right here and a 3 right there. And we know that this is a binomial, which means that the middle terms have to cancel out. And the only way the middle terms cancel out when you distribute is if one is a positive and one's a negative. And let's not forget about the outside 4 that we originally factored out. We need to bring that down. And that's your answer for number 3. Let's take a look at number 5. So number 5, I don't like the way the worksheet did this, but either way, the very first type of factoring that you should do is what? GCF. Now, what is a GCF of 144 and 9? 9 is actually a GCF. So you could pull out a 9, and you will have, let me do it with the calculator, 144 divided by 9, I know it works, it's 16, and then minus 1f squared, so I'm just going to put f squared. Now, I would have actually pulled out a negative 9. So let me do what I would have done on the side. But this is what in red is what the book did. I would have pulled out a negative 9. That way I would have had a negative 16 and a positive f squared. Then I would have changed the f squared to be first minus 16. But they didn't do that. So I'm going to continue with what the worksheet did. On the worksheet, they recognize that there's a perfect square term here, a perfect square term there. So they just jumped right into the answer format, of course with the 9 in front. So what is the square root of 16? 4. The square root of this guy is 4. So we put a 4 there. And what's the square root of f squared? F and f. Now we know that it's a binomial, not a trinomial, so the middle term needs to cancel out. So they put a plus and a minus so that the middle term cancels out. Now I would have pulled out a negative 9 because I like to have a positive f squared. I like to have it in standard form. And then I think it's a little nicer to have a negative 9 and then f plus 4, f minus 4. But the book left it like this with the f second and the 4 first. Doing the odd ones only, guys. Let's jump to number 7. Do we have a perfect square term in the front? Yes. Do we have a perfect square term in the back? Yes. Answer format. What is the square root of 121m squared? 11m. What is the square root of 144p squared? 12p. So we're going to put the 11m again, and the 12p again. Now we know that this is not a trinomial, so the middle terms have to cancel out. So what are the signs? One's positive, one's negative. And that is the final factored form right there. Cool? Number 9, those are not perfect square values, but we might be able to pull out a GCF. What is the GCF that we could pull out? 4? 6? 6 is better? And I don't even know if that's the greatest. We'll find out right now. 6 times what is 24? And how about 6 times what is 54? Perfect. And now if we look at the inside, again we have a perfect square quadratic binomial. So on the inside, I'll be able to take the square root of each, plug it into my answer format, and let's just not forget to bring down that GCF of 6 that we pulled out originally. So what is the square root of 4a squared? The square root of 9. The square root of 9b squared. 3b. And we'll think about the signs later, right? So again, the square root of 4a squared is 2a. The square root of 9b squared is 3b. And now because this is a binomial, there's no middle term, we know that they have to cancel out when we distribute. So one has to be a plus, one has to be a minus. One has to be a plus, one has to be a minus. Doesn't matter which order you go as long as the signs are different. And let's not forget about this 6 that we originally factored out. Bring that down. This is your final factored form answer. So if we look at number 11, we see a perfect square term in the front. We do not see a perfect square term in the back, so we can't apply the shortcut. And then if you start trying a times c to give you the middle value b, it doesn't end up working out, so this is simply prime, not factorable. What could I factor out here? 5 with a q, right? So if I pull out a 5q, what's left over on the inside?
9q squared minus 4.
And on the inside, we do have a perfect square term and a perfect square term. So that inside, let's not forget about the 5q that's on the outside. On the inside, when I take the square root of each of those, what do I have? 3q and 2. 3q and 2. How about those signs? Mixed. It's not going to be plus plus. It's not going to be minus minus because there is no middle term. They have to cancel out. So one has to be plus, one has to be minus. And that's it. So right here on number 15, what's the first type of factoring I should try? GCF. What's in common? What could I pull out of there? Well, there's definitely some t's. How many t's could I pull out?
2.
So t squared. I'd make that weird looking t. But what about numbers? How about the 3 and 48? Isn't there, can I pull out a 3 as well? So 3t squared is the GCF. Because 3 times 16 is 48. So anyways, if I do pull out a 3t squared on the inside, I will have t squared, right? And then minus 16. So you always start by pulling out the GCF. Now after that, you look at the inside, and right there in blue, we do have a quadratic, actually a perfect square quadratic binomial. So, I mean, you could think, what's the square root of t squared? That's t. What's the square root of 16? That's 4. So you have a t and a 4, a t and a 4. And you could think, oh, there's no middle value, so one has to be a plus, one has to be a minus. Or you could do what we always do. Since there is no number in front of the t squared, you could put a t right there and a t right there because t times t is t squared. Now, what times what is negative 16? That if you combine together is the middle value, which is nothing. That would be a positive 4 and a negative 4. Let's not forget about the 3t squared out here in the front. So that's our final answer for factoring number 15. Number 17, there's two ways of doing this problem. I want to show you both. Okay. First of all, this is an equation that they want you to solve, so they want answers. And one way of doing it is to set it equal to 0 by subtracting 9. And then you could rewrite your equation. You will have a 64p squared minus 9 equaling 0. And then you could look at the left side and recognize that it is a perfect square binomial. So I could actually do the square root of this guy and then do the square root of this guy and plug them into my answer format with one being plus and one being minus, because we know that there is no middle term. It's a binomial, not a trinomial. So what would the square root of 64p squared be? What's the square root of 64p squared? 8p. So I put an 8p there and I put an 8p there. And how about the square root of 9? 3. Put a 3 there, put a 3 there. And we're done. We're done factoring. But right here they're not asking us to factor, they're asking us to solve. So we still have this equals 0. And now we are able to split them and solve. So I could rewrite it as 8p plus 3 equals 0. And again, 8p minus 3 could also equal 0. And if we solve both, minus 3, we'll have 8p equaling negative 3. And the final step would be to divide by 8. Divide by 8, and you will get p equals negative 3/8. And on the other one, add 3, you will get 8p equals 3. Then you divide by 8, and you'll get your answer, p equals positive 3/8. That is one way of doing it. Now there's another way of doing it. Whenever we're solving an equation, we always try to get the letter by itself on one side. So I need to try and get p by itself on one side. Now notice that there is no quadratic trinomial. What do I mean by that? There is no p squared and then a separate p. There's just p squared. So I could actually get that p squared by itself. Let me rewrite it. 64p squared equals 9. How do I get rid of that 64? How do I get rid of the multiplication of 64 right in front of the p squared? By dividing by 64. So you divide by 64. So that would cancel. Your new equation would be p squared equals 9/64. Now you want to get p by itself. So what would you do to get p by itself? You do the opposite of a square. And what's the opposite of a square? A square root. Okay? So we're going to apply a square root to make that a regular p and apply a square root over here. Now, whenever you do apply a square root in an equation, you end up with a positive situation and a negative situation, which we call as a plus or minus. And then over here, you actually have to split that root and do the square root of 9 and do the square root of 64, and you end up with 3/8. So there's your answer. P equals plus or minus 3/8. Now, what does plus or minus actually mean? It means that it could be positive 3/8 or it could be negative 3/8. Notice that that's exactly the answers we got with the other method. So it's totally up to you if you want to start applying square roots on equations to get a p by itself, or if you want to factor, split, and solve. It's totally up to you. Let's move on, number 19. So it's up to you. Do you guys want to get k squared by itself and then apply a square root? Or do you want to factor, split, and solve? Pick one. So if we want to go with factoring, what's the GCF? So if you wanted to factor, the GCF, you could pull out a 2. And if we do pull out a 2 from this equation, what are we going to have left on the inside? 16 minus 81. Of course, with the k squared right here. And now that you look at the inside, you have a perfect square binomial. It's weird because there's a number first, but that's okay. But both of them are perfect square terms. So if you square root them, you'll be able to plug them into your answer format, Adrian. So the square root of 16 is 4. The square root of 81k squared is 9k. So you put the 4 and the 9k. And of course, since there's no middle term, one has to be a plus, one has to be a minus. Let's not forget about the original GCF of 2 that we pulled out. Now this is an equation set equal to 0. So now we're able to split them and solve. Now if you're thinking, what about this 2 right here? Because it's an equation, you could just get rid of it by dividing by 2. And as long as you do it to the other side, divided by 2, it's still going to be 0 on the right side. So what we're going to do is split each of them. 4 plus 9k is equal to 0. And also 4 minus 9k is equal to 0. So when you solve minus 4, you're going to get 9k equals negative 4. And the final step would be to divide by 9. So k equals negative 4 over 9. Now the other answer is going to be positive 4 over 9. Let me just show you quickly. Minus 4, minus 4. You're going to have negative 9k equals negative 4. Final step, divide by negative 9, divide by negative 9. So your k does equal positive 4 over 9. And let me tell you this, I think we're going to stop right there. I'm not going to, you could, these are pretty easy as well. Like number 21 is pretty easy. Let me show you how you should do it. You should subtract 16 over 49. You should subtract 16 over 49. And then you'll have a new equation, negative v squared equals negative 16 over 49. But then again, that minus sign, you don't want it to be negative. You want it to be a positive. So you divide both sides by negative 1. That would change both signs. So you would have v squared equals 16 over 49. And to get rid of the v squared, to just have v, you'd have to apply a square root. So when you apply a square root on one side, you have to apply a square root on the other, which means that your answer will be plus or minus. And the square root of 16 is 4. The square root of 49 is 7. So it's plus or minus 4/7. I'm not going to give this to you on the test, but it is important for you to know for Algebra 2. If you're wondering where that plus or minus comes from, I might as well explain it right here. Let me go to the side. See, if we had the equation x squared equals 9, what would the answer be? What's the answer right there? 3. But there's another answer. Negative 3 also works. Remember, a solution to an equation is the value that'll make it true. So yeah, you could put a 3 in there. That'll make it true. But you could also put a negative 3 in there, right? That'll also be positive 9. So in reality, the answer to x squared equals 9 is x equals plus or minus 3. X equals 3, x equals negative 3. It's both of these answers. So the quick way to write it is x equals plus or minus 3. And that's where the rule came about, that when you apply a square root in an equation, you must put a plus or minus in front of your answer. So when you do the square root of 9, you get 3, but you have to put that plus or minus in front of the answer, 3. Anyway,